In this tutorial, we will be looking at some basic electrical concepts and terms that will help you to understand the magic of electricity.
Okay. It really is like magic to me. How does electricity really work?
First, let's start simple. Everything around us is made up of tiny particles called atoms. These atoms have even smaller particles called protons, electrons, and neutrons. Protons are positively charged and are located inside the nucleus of an atom. Electrons, which are negatively charged, orbit around the nucleus. In their neutral state, atoms have an equal number of electrons and protons. However, electrons can become free from its orbit by an external force. These are known as free electrons, as one electron leaves a void, which can be filled by another electron forced out of the orbit from another atom. As free electrons move from one atom to the next, an electron flow is produced. This, my friend, is the basis of electricity.
Whoa, you just blew my mind. Okay, so where does this external force come from?
In order to get the electrons to flow, the potential of the source has to be greater than that at the end. Imagine it as water running through a garden hose. We must first introduce water with some sort of pressure so that it ends up at the other end of the hose.
Okay, I get it. So it can be created from a water pump or even gravity.
Exactly. In electrical terms, this is called voltage. The water running through the hose is considered the amperes. Now imagine if a hose had a nick or is obstructed by some debris. This will cause the flow of water to slow down, right?
Yes, that makes sense.
This is called resistance. In an electrical current, the flow of electrons can be slowed down by applying some resistance, also called ohms. To summarize, electricity can be divided into three basic principles: volts, amps, and ohms.
Volt is pressure, amp is flow, and ohm is the resistance of that flow. Hey, I'm learning here.
That's great! Now we can use those three units to measure how much electricity we need to get the job done. For this, we can thank German physicist Mr. George Ohm, who invented the Ohm's law formula.
Interesting. And how do we apply it?
To remember the formula, it is commonly used in the form of a triangle, where E equals voltage, I equals current, and R equals resistance. To use a triangle, simply point to the value you want to calculate, and the remaining letters make up the formula. For example, if we cover up the E at the top, the formula will be as follows: E equals I times R, or in other words, to find out the voltage, we simply need to times the current by the resistance.
I understand now. How about if I want to know the power of some sort of a load?
Great question. For this, my friend, we use the formula known as PIV, where P equals power or wattage, I equals current, and V equals voltage. For example, let's say you have a TV that uses 1.5 amps, and it plugs into the outlet of your house that we know is 120 volts. Therefore, we use this formula. 1.5 amps times 120 volts equals 180 watts.
180 watts? Cool!
It sure is. And now we need to find watt hours, which is the amount of power in a given length of time. For example, let's say that you watch TV 5 hours a day. Well, we know that your TV needs 180 watts to run, so we can calculate it as 180 watts times 5 hours equals 900 watt hours.
Brilliant! Man, I need to watch less TV.
And if you reach 1,000 watt hours, then it would be equal to 1 kilowatt hour.